The Earth's atmosphere is made up of gases that protect the planet from damaging solar winds, solar radiation, and cosmic rays. Although 99% of atmospheric gases are non-reactive, the remaining 1% can trap heat and are called greenhouse gases. Solar energy is able to pass through the accumulated gases in the atmosphere, and some of the energy is absorbed by the Earth's surface. The remaining energy not absorbed reflects off the surface and travels back into space. However, the reflected energy doesn't completely pass through the atmosphere. Some of the energy is absorbed by water vapor and greenhouse gases and gets trapped as heat. The Earth has always had a natural cycle of greenhouse gases. Without these gases trapping heat, the Earth's surface temperature would be 0 degrees Fahrenheit or negative 18 degrees Celsius. However, due to human sources since the Industrial Revolution, greenhouse gases have been increasing in the atmosphere at a faster rate than any in geological history, overthrowing the natural balance and causing a rapid, uncontrolled increase in the Earth's surface temperature. This resulting problem leads to climate change and has many damaging consequences, such as rising sea levels, changing ocean chemistry, and volatility of weather patterns, including an increase in large wildfires, heat waves, and droughts. Carbon dioxide, nitrous oxide, and methane are among the dominant greenhouse gases with the greatest lasting effect on atmospheric temperatures. Strategies to decrease these greenhouse gases therefore have the most potential to effectively reduce the overall greenhouse gas effect and decrease climate change impacts. Carbon dioxide has the highest concentration of any greenhouse gas in the atmosphere. Major naturally occurring sources of carbon dioxide include biological respiration and ocean release. Respiration involves the production of energy as oxygen undergoes a series of reactions to break down carbon compounds to create energy, with carbon dioxide and water vapor as byproducts. Most of the carbon compounds used for energy production come from plants and algae, which use the carbon dioxide in the atmosphere to grow. Carbon dioxide is constantly being exchanged between the atmosphere and ocean as well. The ocean absorbs CO2 from the atmosphere, and through the process of diffusion, carbon dioxide is released at the water surface back into the atmosphere. This circular cycling of carbon between atmosphere, plants, plant consumers, and the ocean has been altered by the geologically sudden release of carbon dioxide from fossil fuels following the Industrial Revolution. Fossil fuels consist of coal, natural gas, and oil and are widely used as effective sources of energy. Before the Industrial Revolution, carbon cycling depended on carbon that was produced and released by living organisms in the ocean. Although the original sources of coal, natural gas, and oil were at one time living organisms, geologic forces stored those carbon sources deep within the Earth's crust and locked them out of the active global carbon cycle, therefore giving them the name fossil carbon. As a result of the Industrial Revolution, humans have extracted fossil fuels from the Earth's crust and burned them for energy, releasing carbon dioxide and water into the atmosphere as byproducts and heavily contributing to the greenhouse gas effect. In fact, about 87% of emissions from human sources is due to fossil fuel burning. Only 6% of human emissions occur as nitrous oxide, but this greenhouse gas is 300 times more effective on climate change than carbon dioxide. Human activities have offset the natural balance of the nitrogen cycle and are held responsible for doubling natural inputs of nitrous oxide since before the Industrial Revolution. Soils under natural vegetation are responsible for majority of natural nitrous oxide emissions. Microbes in the soil break down nitrogen, producing nitrous oxide as a product of the natural microbial process. However, use of fertilizers in agriculture has caused soil emissions of nitrous oxide to increase rapidly. Synthetic and organic fertilizers are common methods in agriculture and are considered the largest source of nitrous oxide emissions from human activities. Fertilizers apply nitrogen directly to the soil, and microbes utilize this additional nitrogen as additional energy, generating further nitrous oxide emissions as a product of the microbial process. Methane emissions are 28 times more powerful than carbon dioxide. It only contributes 16% of greenhouse gases in the atmosphere. Natural emissions of methane are mostly from wetlands, where high soil moisture content and depletion of oxygen and decomposing organic material form a perfect environment for methane-producing microbes to thrive in. Human-made methane, however, accounts for 64% of total methane emissions. Natural gas and petroleum are the largest sources of methane emissions due to methane being the primary component of these energy sources. Methane is released throughout the entire procession of natural gas. Methane leaks occur during extraction and refinement of natural gas. Methane gas emissions also occur during distribution and use or combustion of the natural gas. Another major human source is domestic livestock. The normal digestive process of livestock, such as cows, release methane as a waste product via belching. As more livestock is farmed to support an ever-increasing human population, greater amounts of methane enter the atmosphere. The concentration of greenhouse gases in the atmosphere has been increasing, causing an upset in the gas's natural cycle. This is causing a rapid increase in surface temperature of the planet, and to reduce this greenhouse gas effect and decrease the damaging consequences, society must act to reduce greenhouse gas emissions from human sources. This can include increasing the use of renewable energy sources, improving fertilizer and livestock practices in agriculture, and generally reducing waste. Scientists play a pivotal role to educate the population about harmful effects of global warming and influencing the leaders to take action, as well as developing technology to combat the problem.